guys, welcome back. 1.4, we're gonna build functions from functions. And so basically we're gonna have two functions. We're gonna do operations between those two functions, two different functions. And then we're gonna find the compositions of two different functions. And each of those we're gonna be finding domain of the function. So let's just go ahead and get started. So we have the sum, difference, product, and quotients of functions. So if we're given two functions, and so these f and g, we're going to have two functions with intersecting domains. And so for all values of x intersection, you have these following rules. So the sum, if you have f plus g, all you're doing is adding the function of f plus the function of g. So you're adding these two functions together. That's all this is saying. F plus g of, wow. Okay, real quick, okay, I'm gonna, as I do this, I'm gonna talk. So, functions of f, we're gonna add, subtract, multiply, or divide to functions of g. You can see any variable here. Mostly you're gonna see f and g, f and g. And so we're gonna do that with your domain. It's important to realize, so you have finding your domain of f, and you're gonna find your domain of g, and whatever operation you do between, it still follows the following function, domain and range, okay? And then you may have to look at some more limitations, but if we have each case, the domain of the new function, it consists all of the new, old domain of the f and the old domain of g, okay? And so like if you have the difference, you subtract, make sure here you're gonna distribute that negative if you need to. Okay, f times g, and then f over g, provided that g of x cannot equal 0, because remember that's illegal in math, okay? And so let's look at some examples. So we're gonna do all the products of f of x, which is x squared, and g of x, which is the square root of x plus 1. Okay, so finding the formulas for the function. So first we're going to do f plus g, and so all that is f plus g of x. Okay, actually I'm gonna back up. Okay, we're gonna find the domain of f and then find the domain of g before we get started, because those domains go and they're utilized within the new function, the operation of them too. And so we need to refer back to that, and that always takes over whatever the domain is of the operation. Okay, so for f of x, x squared, that's a parabola. It goes forever left, forever right. And so the domain here for f of x is negative infinity to positive infinity, okay? And then for g of x, we have the square root of x plus 1. Square root, under that, we cannot have a negative. So this is saying x plus 1 has to be greater than or equal to 0. If we subtract 1, our x has to be greater than or equal to negative 1. So this domain would be negative 1 to positive infinity. So now we're going to utilize that. So this kind of takes over. This is going to be your domain, essentially, for all of them, okay? Because we have a limitation on one of our functions. And so that limitation is applied to each operation. So f plus g of x would be just x squared plus the square root of x plus 1, okay? We cannot simplify that at all. And so our domain is going to be the limitation of g of x, which is negative 1 to positive. That's a horrible infinity sign. There we go. Okay, f minus g of x is equal to x squared minus the square root of x plus 1. Okay, we can't distribute that because that's under square root. The domain here is the same, okay? That g of x has the limitation, and so that is applied to our oh my goodness gracious, golly gee. That is okay, negative 1 is included. Positive, I don't know why I did that. Infinity's not included, I'm so sorry. Okay, and then let's do f times g. If we have f times g of x, so we're just multiplying these. And so that'd be x squared times the square root of x plus 1, okay? We cannot simplify that anymore. We can't distribute under the square root. Domain is the same. Still has that limitation of -1 to positive infinity. Okay, now let's do f divided by g. So f over g of x is equal to, we have x squared at the top and then the square root of x plus 1 at the bottom. Okay, so we could rationalize this denominator. If we take this, the square root of x plus 1 over the square root of x plus 1, that would be x squared over x plus 1. I'm just going to leave it like here. However, let's talk about our domain. So we know it's from -1 to infinity. That's g of x. But if we look at our new function, if -1 is a part of our domain as an x value, -1 plus 1 is 0. Square root of 0 is 0. Okay? That would give us an illegal number. So with here, our domain is still from -1 to infinity, except our -1 is now not included. If -1 was included, we would have an issue. Okay, so you gotta look at that. Let's talk about g of g. So g times g of x. Okay, that would be the square root of x plus 1 times the square root of x plus 1. And then put our parentheses on the outside, so that's like that squared. Okay, you could go ahead and, square of a square root would just be x plus 1. That would be simplified. And then let's talk about our domain. So if we talked about this domain of x plus 1, well, technically that's all real numbers, okay? However, we had a limitation for g of x, this -1 to infinity. That is still applied with the operation. So even though the simplified form is all real numbers, since we had the limitation for g of x, our domain here is still -1 to infinity. We don't have an issue with denominator, so -1 is back to being included. Okay, so domain is all this except for this one. You had to be careful with this denominator. Okay? And then let's talk about composition of functions. Okay, so for composition of functions, all it is if you have an input. So if you put an input into one function, you get an output out. Whatever that output is becomes the new input for another function. So we're putting one function into another function to find your new output. Okay, so you have an input that goes into a function. The output becomes the new input for another function, and that output is your answer. Okay, and so it's denoted as, it looks like fog, that's like an open circle. I do not, you're going to see that, that's how it's going to ask, find f of g, and that's what it's saying, f of g. I always rewrite it, okay? F of g is the same thing as f of g of x, okay? This right here is how we work it. We work it from the inside out. Kind of like with parentheses. If you think with parentheses, you work it from the inside out. You simplify from the inside out. Same with this, okay? So f of g, and you can reverse it. If it's g of f, it would be, g of f of x. And it's the same thing about the domain. You have to look at your domain of g and domain of f. Look at your new composition of that function and find your domain in range, okay? And so this is kind of a little mapping. So this f of g, which is f of g of x, okay? So if we have this x value in g, which is this number, it goes into g and we get g of x. Once we get this number, once we get this number, which is this number, it goes into f of x. And whatever that output is our f of g of x, okay? So let us look at some examples. And so we're going to do 2 examples, one with numbers, okay? And a little hint here, if we have f of g of a -2 and then g of f of -2, since those are numbers, our answer is going to be a number, okay? If those are an x, our answer is going to be in terms of the x variable. So a little key there. So we have f of x is equal to -3x plus 1, and then we have g of x is equal to x squared plus 5. So because we just have the numbers, we can just go ahead and solve just the way they are. We don't have to worry about domain and range. And in this case, our domain we're given is -2. That's our input for first g and then second f. But So let's just go ahead and get started. So first, f of g of -2. I'm going to rewrite this. I'm going to say f of g of -2. Okay, so all I did was rewrote it left to right, so it looks like this. I always rewrite it. Okay, so what this says is our input, we're going to work on the inside out. Our input for function g is going to be a -2. So we're going to plug in this -2 in for g. So that would be f of, just ignore that for now. I'm actually going to write that in red still. F of, and then in g, we're going to put -2, which is right here. So we're going to say -2 squared plus 5. Okay, and then close our red parentheses. So we have -2 squared. -2 squared is 4, so we have 4 plus 5. 4 plus 5 is 9, okay? And so our output for g of -2 was 9. So that becomes a new input for f. So now we're going to plug in that 9 into our function f, which is -3 times 9 minus 1. -3 times 9 is -27, minus 1 is -28. Okay, so that answer is -28. Now let's do g of f of -2. Okay, so rewriting it, I'm going to say g of f of -2. Okay, so our input is going to be -2 into the function f. So we're going to put, now we're going to start with the function f and put in -2 there. And so I'm going to bring down this g of, and then look inside here first, inside out. So f of -2, our input's -2, in for x, so we're going to say -3 for -2 minus 1. -3 times -2 is 6, minus 1 is 5. Okay. So our input of f of -2 is 5, and our output is 5. So that output becomes a new input for g. So we get g of 5 is equal to 5 squared plus 5. Well, 5 squared is 25 plus 5 is 30. So f of g of -2 is -28. G of f of -2 is 30, okay? And there we go. That's how we do compositions of functions with numbers. I think that that's easier, honestly, because you don't have to worry about domain or range. You just plug them in, find a number. Okay, now let's do a composition of domain and in terms of x. So let's look at f of x and let's look at g of x. And again, I'm going to establish the domains of each before we get started, just to kind of keep that in the back of our minds. Okay, so we have f of x is equal to x squared minus 1, and then g of x is equal to the square root of x. So square root of x plus 1, not square root of x plus 1, just x squared plus 1. That's all real numbers. And then g of x, the square root of x, this needs to be, x needs to be greater than or equal to 0, okay, which means we have from 0 to positive infinity, okay? So that's for g of x. So if we're gonna do g of f of x first, so a, we're gonna do g of f of x, okay? So f of x is x squared minus 1. So we're going to do g of x squared minus 1. So now our input is x squared minus 1 into the g function. So that would be the square root of x squared minus 1. Okay, and so since we plugged in f into g, we just need to look at this domain, okay, because there is no restrictions on the f, so we're good. There were restrictions on the g, which is now this. So what we're going to do is look at what our domain of square root of x squared minus 1. Okay, so if we wanted to write like the g of f of x is equal to the square root of x squared minus 1, and now we need to find our domain. And so we need this under the radical to be greater than or equal to 1. So we have x squared minus 1 is greater than or equal to 0. Okay, add 1, cancel. We have x squared is greater than or equal to 1, square root both sides. So we have x is greater than or equal to plus or minus 1. Okay, if we look, this is a greater than or equal to, so that means this is a union. So this is an OR problem, and so they're going to be a part. So we have our negative infinity to negative 1 included with the union of 1 to positive infinity. And that would be your domain for g of f of x. Okay, and then if we look at B, which is f of g of x. Okay, so we're going to start here with our inside is g of x. Okay, and so we have a parameter here, so we're going to have to watch that. So we're going to plug in that square root of x into f. So we have f, and then we have the square root of x. Okay, and so that square root of x goes into there. So that'd be the square root of x squared minus 1. Okay, we could simplify that, and the square root of x squared would just be x minus 1. I'm going to leave it like that, and then let's talk about our parameters because that was g of x. So we're going to look at this domain, and so your domain here would be 0 to positive infinity. Okay? So that's that. There's only 4 questions in your Math Excel. Hopefully you're good to go. I know the domain and range part I think is kind of new, especially the notation, but I think you guys will be great. Let me know if you have any questions. Bye.